चलो मैं ये वाला कर रहे हैं। अच्छा सर, आवाज आ रही है?
Yes, sir. Yes, sir.
अच्छा, so we're starting with the first one. Okay, complete a table of information of two of the particles in an atom of AU 197. ठीक है. So location बता दो. It's simple. What's the location? Electron.
It's on the shell, sir.
Yeah, that's shells. Relative mass of a neutron क्या होती है? Relative mass.
Is it one, sir?
It's one. ठीक है. Relative charge at zero. Total number EU 197 इसमें देखो कि what's the total number of neutrons? क्या होता है? Do we have a periodic table? Just a second.
Or it might be 118, sir.
You get 118. The next thing is state the type of bonding in gold. What's क्या होगा? That's metallic. Explain what is meant by the term isotopes. क्या है वैसे? Word definition क्या है?
Atom of the same element with the same number of protons with different number of neutrons.
ठीक है. A different, so same number of atoms of the same element with the same number of protons but different number of neutrons. A different sample of gold contains more than one isotope. Suggest why the different sample of gold has the same chemical properties as the sample found in Earth. So why do all isotopes have the same chemical properties?
Is it because they're the same elements, the atoms of the same elements?
हाँ, लेकिन just 1 second. Hold on 1 second. इसका देखो, they have the same electronic configuration.
Okay.
Okay, next one. Calculate the percentage abundance of gold X in the sample of Tumbaga. Tumbaga is an alloy of copper and gold. So calculate the percentage abundance of gold. ये gold की percentage निकालो. What's the percentage abundance of gold? How do you find that?
Oh yes, sir. This is the topic I was talking about, sir. Percentage abundance.
So percentage abundance के वैसे percentage abundance is you'll if you do mass spectroscopy, you get what you get is different percentages of each element, right? So total percentage क्या होगी? That's going to be 100%, right? So you've got some of this, you got some of this, you got some of this is gold. ठीक है, it's copper and gold. So these two are coming from, these are isotopes of copper. ठीक है, so that's your copper, and this is your gold. तो इसका बताओ कि what is the percentage X? How do you find that? I mean, the total is 100%, right? So it's going to be 100%. और फिर 20 में से you're going to subtract copper, which is 56.36%. And minus 25.1514%. So क्या बन रहा है? What are we getting?
18.5, sir.
ठीक है, so you're getting 18 point. So you're getting 18.5%. Calculate the relative atomic mass AR of the copper present in the sample. Give your answer. So now he's saying calculate the mass. This guy, I just opened some questions, TK. We'll do some questions first just for practice. So अच्छा, इसके अंदर I'll just do some questions related to AR. 1 second. So here's an example of an element that has many different isotopes. Okay, so you've got cerium, which has all these isotopes, and all those isotopes have different masses. Okay, so you've got 135 and you've got 137. Okay, these are your different masses that you have. Our percentage abundance is given for each one of them. The first one, can you calculate the percentage abundance of the fourth one? Okay, so the total should add up to be equal to 100%. So it's going to color what is the percentage abundance of this one, the last one.
So that one is 11.114.
11.114. So this one is 11.114%, right? So that's 11.114%, and so how do you? They've given you the AR. The AR is the average of all the isotopes. There's a simple formula for calculating the average, the relative atomic mass, which is the average mass of an atom compared to 1/12 the mass of carbon-12. So it's the average mass of all the isotopes. Okay. So what happens is, it's the average mass of all the isotopes, and the way you calculate this is कि आप सारों को ना add up कर दो, all the percentages multiplied by the values, by the isotopic mass, and then what you do is you divide by 100. Okay, that's how you calculate the average atomic mass of an atom. So we're just going to do that. We know what the AR is. The AR is already given to us. It's 140.116. We know how this is calculated. Okay, you take the percentage. So what the percentage for the first one is 0.185, and it's going to be multiplied by what? 135.907. Here's second one. What's the percentage of this second one? That's 0.251%. And that's going to be multiplied by its mass, which is 137.906. The third one, that's 88.450% multiplied by its isotopic mass, which is 139.905. And then you have a third one, which is, sorry, the fourth one, which is, you know, the percentage, which is 11.114 multiplied by X. You don't know what X is. And the whole thing gets divided by 100. So solve for X now, okay? So ये आपका formula होता है. This is how you calculate the average of all the isotopes, okay? ये निकालो क्या आ रही है value? You can take 100 over here. This will become what? Sorry, times 100.
So 141.915.
So you're getting 141.915.
15.
ठीक है, तो ये आपके पास आ गया. ठीक है, you're getting 141.915, and so that is approximately. Remember, isotopic mass is something, mass that depends on accuracy. It's always in decimals. So it's very close to the nuclear number. It's so if you're getting a value that's very close to 142, that means that is क्योंकि हर proton neutron की जो approximate mass होती है, that is approximately 1, but approximately 1, not exactly 1. So which is why your mass numbers are always something close to the number of protons and neutrons, but not exactly the same value. ठीक है? So that's how we're going to calculate this one as well. कि ये जो paper था ना, इसके अंदर they've told us that there's Tumbaga, which is an alloy of copper and gold. So this is my copper and this is my gold. First thing that he asked was, okay, what is the percentage of gold? So I know that the total of this is 100%. So if this is 56.36, this is 25.14. So 100 में से minus करो, so you'll get what X is. ठीक है? So you'll know कि the amount of gold in the sample is 18.5%. The next thing is that they're asking for the AR of copper. So how do you calculate the AR of copper? That's the sum karo percentage abundance multiplied by the isotopic mass. And you're going to divide all of this by 100. So we're just going to do that. So the AR in this case, isotopic mass in this case is, the percentage for the first one is 56.36 times the isotopic mass, which is 63, plus the other one, which is 25.14, multiplied by the isotopic mass, which is 65. ठीक है? तो उसकी percentage multiplied by the isotopic mass. और फिर divide by किससे करना है? किससे divide करना है? Divide by the total percentage, right? The only problem in this case is that over here the sample is contaminated by gold. So you're not going to divide by 100% because you're only looking at copper. You don't need anything to do with gold. You're just trying to figure out the AR of copper. So the total is not coming out to be 100%. So what is the total coming out to be? 56.36 plus 25.14. क्या आता है? What is 56.36 plus 25.14?
81.5.
So what's 81 point? So usually it is divided by 100%, but since the sample is contaminated, so not all the 100% is actually copper. Copper जो है ना वो सिर्फ 81.5% है sample का. So you're going to divide it by the total in this case is 81.5. So what do we get for this?
63.6.
Okay, so we're getting 63 point. Also, 2 decimal places का हुआ है in the question. So what do we get?
63.61. 63.61.
63.61. ठीक है. अच्छा अगला part quickly. It's about inorganic. ठीक है. It's about inorganic. Let me just open the inorganic notes as well. 1 second. So starting with the first thing. So yeah, needs way this one. Starting with the first thing, type of bonding. Mg and Al are obviously metallic, right? And the rest are covalent, right? All of them are. So which ones are the bonding device कर लेते हैं, ठीक है? What is the bonding in PHC? Remember, Na, Mg, and Al, they're all the first three are metallic. Silicon, phosphorus, sulfur, and chlorine are all covalent. Argon is a monatomic gas, doesn't really bond with anything. One of them is a giant covalent structure, macromolecular, that's silicon. Okay, that's why it's got very high melting points. NaMg and Al are all metallic, but remember metallic bonding, its strength increases if you have more delocalized electrons. So aluminium has a higher charge as well as more delocalized electrons in the metallic lattice. So which is why it has a relatively higher melting points. Okay. Next part, formula of the oxide, Na is +1, तो क्या फॉर्मूला होगा? Na का क्या होगा? Manisha, answer this one. Na का क्या होगा? Formula.
Na2O,
Mg would be.
MgO,
The next Al,
AO2O3,
and then you
SiO,
have SiO.
SiO.
ठीक है, the same thing. AlCl3, SiCl4. This one could be PCl3, it could be PCl5 as well, right? This one. Actually, it's chlorides, man. Okay, in the oxides as well. Manisha, which ones are ionic in the oxides? Ionic कौन से? The first three are ionic. SiO2 is a giant covalent. P4O10, these are simple covalent molecules, right? In the chlorides, remember, AlCl3 is covalent. All of them are simple covalent. The first two are ionic. He's asking for the dot and cross diagram of sulfur with chlorine. Chlorine forms a single bond. So out of 6 electrons, group 6, sulfur makes 2 bonds. So there are 4 electrons left. Chlorine is in group 7. So 7, 1 electron used up, 6 are left. अच्छा फिर क्या कि I think it's in exothermic reaction. So exothermic reaction, the graph should be lower. This is where you'll have SCl2 liquid. You have to label it. That's your delta H. That's your activation energy starting at. So I guess that's about it for 2 marks. Next point is sketch the melting point trends from Na to S. So that's what we just saw. Na has a low melting point, Mg has a slightly higher melting point, Al has an even higher melting point. Silicon has a very high melting point. Phosphorus then has a very low melting point. Sulfur has a slightly higher melting point compared to the So give these statements. You have to explain your entire structure. So starting with, we can start with silicon. Tell them that it's a giant covalent structure. So strong covalent bonds. Phosphorus and sulfur. Tell them that they're simple covalent with weak intermolecular forces. And they've got weak van der Waals forces. Tell them that they've got strong covalent bonds. So the third one is you can talk about the metallic bonds, NaMgAl. They have metallic bonds. And its strength increases as you have more delocalized electrons. As you have more mobile electrons and higher cationic charge. So you've got a higher charge on cation. Write an equation for the reaction of P4O10 with water. What acid is formed when P4O10 reacts with water?
Phosphoric acid, sir.
Okay, so remember the reactions of oxides with water. So we're talking about P4O10, that's going to form HCPO4. If you were talking about P4O6, it would form phosphorus, SO3, SO2. So these are the reactions. Remember those. Now, SO2 can be released into the atmosphere, and fossil fuels containing sulfur are burned. State explain environmental consequences. So, क्या होता है SO2? What is the state and then explain. Okay, environmental consequences for S2.
So the formation of acid rain, sir.
So it's the formation of acid rain. उससे फिर will explain consequences क्या होंगे?
Decreases the pH of soils and lakes and rivers.
ठीक है, so it increases environmental consequences, decreases the pH, right?
Yes.
And so it decreases the pH of the soil. So the elements in the third pair show a general increase in the first ionization energies from left to right. Identify two pairs of successive elements in the third pair that do not agree with the statement. For each pair, so this is about the dips ke period C ki baat kar rahe hain. So this is how there's a dip at group 3, there's a dip at group 6. So this is Na, Mg period C. Then you've got Al, you've got Si, you've got kya tha Si ke baad phosphorus. There's a dip at sulfur, then Cl, and then argon, right? So the pairs that you're going to identify are first one. It's the Mg2Al. There's a dip at Al. Kya reason hoti hai? Why is there a dip at Al?
So an Al, an electron is moved from a high energy P subshell, which is further away from a S subshell, has more shielding.
ठीक है, Al की जो electronic configuration is 3s2 3p1 while Mg was 3s2. So easier to remove electrons from a higher energy. So electron removed from a higher energy p subshell which is more shielded so easier to remove electrons. Uska kya hoga? The second pair, which is where you have a dip.
Sulfur and phosphorus.
ठीक है, उसमें what's wrong with sulfur then?
There are more valence electrons in sulfur, which causes repulsion. And it's easier to remove the electrons.
नहीं, exact बताओगे. It's sulfur is S2P4. P4 is 211, right? Phosphorus is S2P3. That's group 5 जो होता है S2P3 होता है. So PX1, PY1. So sulfur के अंदर there's a paired p subshell. Which causes electron-electron repulsion or electron spin pair repulsion. So उसकी वजह से electron-electron repulsion होती है, and that's why it's. So you just have to write that in sulfur electron is removed from a paired p subshell, while in phosphorus electron is removed from an unpaired p subshell, and there's spin pair or electron-electron repulsion over here. ठीक है? Clear है बात?
Yes, sir.
Yes.
अच्छा, फिर next part is you have to find, how do you find enthalpy change? Enthalpy of formation of everything is given. Products की भी given है. And you're given enthalpy of formation of the reactions as well. Kya formula for finding enthalpy change?
So the HF of products minus the HF of reactants.
ठीक है, so it's the product minus reaction. So it's going to be 692.9 plus 3 AGI. That's 3 times minus 61.8 ये product हो गए minus reactants. Reactants are CH3, CHI3, that's minus 182.1. और फिर क्या CAGF, that's 3 times minus 204.6. तो ये निकालो क्या आ रहा है.
Minus 82.4.
ठीक है, kilojoules per mole. Then you have three basic assumptions of ideal gases. What are the three basic assumptions of ideal gases? क्या होती है?
So negligible intermolecular forces
ठीक है, negligible, that's one.
and volume occupied by a gas molecule is negligible compared to total volume occupied. The
ठीक है.
gas. And
Third क्या?
gas molecules are rigid spheres, is it? Or is it the random motion one?
नहीं, और भी बहुत सारी assumptions हैं. Rigid sphere is one of them, but the more important one is that the collisions are elastic.
Ooh.
That's the third one. That the randomly colliding and all the collisions are elastic. Here, explain why it deviates from ideal gas at pressures greater than. So if you increase pressure, why does the gas deviate from ideal gas behavior?
So the particles become closer together and then the gas becomes incompressible. The P relationship with the 1/V fails. V no longer decreases.
Yeah. Basically, wo particle volume is no longer negligible, right?
Hmm.
So if you are at a higher pressure, volume decreases. And particles are like really close to each other. And particle volume is no longer negligible. It's not going to be any more negligible. Next one, write an equation for the reaction of Cl3 with O2, CH, Cl3, CH, Cl3, O2 के साथ. He gave us that. He said that HCl gas is also released as a product. What is produced? This thing. What is this thing? COCl2, I guess. I think it's a diacyl chloride, something like that. Now he's asking, ये कौन सी absorption होती है at 1600? $1600 पे कौन सी होती है? But data booklet, where's the data booklet? 1600.
What's the C double bond O1?
Yeah, that's a C double bond O, right? So that's probably the only absorption that you can see. So that's it. On the infrared spectrum, the carbonyl identified with the absorption that would not be present. So ये नहीं present होगी ना. In CHCl3, you don't have this. It does not have. So ये जो absorption है ना at 1600, वो data booklet से ना exact values quote कर लेना. So this absorption is not going to be there. Suggest another difference between infrared spectrum. और क्या difference होगा? CH का bond होगा. This is somewhere around 2800 to 3000. Well, the exact value I can Like CHCl3 will have that. The molecule that they are talking about doesn't have a CH bond, right? तो डेटा बुकलेट में CH कहाँ पे है? वही है 2800 to I guess 3100. ठीक है. But 2950, we're talking about an alkane over here. तो ये range लिखते हैं ना, ठीक है, this one. You're going to see an absorption for CH3F. Is this clear? Sorry, CHCl3. Clear है? बाकी वो
Yes,
कह रहा है
sir.
कि अच्छा you've got an aldehyde HCN और NaCN के साथ क्या होता है?
It's a nucleophilic addition.
ठीक है, so you're going to have nucleophilic addition. जिसके अंदर the carbonyl group will turn into an alcohol and a nitrile at the same time. So it's this reaction that the CN will get attached to acetyl bond O. So the O will get attached to H at the top and the CN will get attached at the bottom. So ये reaction आपके पास आ गया, ठीक है? So this thing will turn into sulfuric acid में क्या हो रहा है फिर यहाँ पे? What is happening over here?
Which is it? Hydrolysis of the nitron.
ठीक है, that is hydrolysis. वो ये वाला part है कि nitriles they turn into carboxylic acid if you use dilute acid. ठीक है, that's what's going to happen. So the CN will turn into carboxylic acid. फिर reaction C में क्या हो रहा है? That's an alcohol gets removed and it turns back into an alkene. So how do you turn an alcohol back into an alkene? के alcohol को dehydrate कर लो, ठीक है? With SiO2, Al2O3 plus heat or concentrated sulfuric acid plus heat. So you can do all of that and it will turn back into an alkene, ठीक है? तो यहाँ पे I guess it's going to be Al2O3 plus heat. तो आपका OH जो है वो और साथ वाले से ना H चला जाएगा, ठीक है? So you'll get a double bond in between. How do you turn an alcohol into a ketone? वो किस तरह होता है?
Oxidation, sir.
ठीक है, that part is oxidation. So you just use K2Cr2O7. Acidified and reflux. So anyways, वो सारे उसने conditions वगैरह मांगी होंगी. Explain what is meant by the term optical isomer. What's an optical isomer?
Also, is it mirror images that are non-superimposable? Is it?
The definition की optical isomers. That's so optical isomer. अच्छा, what is meant by the term optical isomer? ठीक है. Sorry, मैं समझा stereoisomers. So optical isomers are formed. When are they formed? When you have a chiral center. ठीक है, that's one requirement. And what does that chiral center do? It's going to have non-superimposable mirror images. ठीक है, so the geometry of the molecule around the carbon will have two versions which are non-superimposable mirrored versions of each other. Is that clear? और फिर उसे Q के अंदर he's asked you to show this. So which of the carbons is chiral? It's this one, right?
Yes, sir.
तो उसको आपने फिर show करना है कि as two non-superimposable mirrored.
Oh, sorry, it could also be. Could it also be the cyanohydrin that's formed?
Where's this? I mean, he's just talking about this one.
Oh, okay.
Q का क्या है ना उससे? फिर ये कि R can be used to make a polymer W in two steps. Draw a repeat unit of R. What is R? R is this one. So it's got a double bond And as it's got a double bond HH लगे में है. So how do you it will start forming linkages with the neighboring carbons, and the double bond will turn into single bond. Is this clear?
Yes.
So that's how your polymer is going to be.
So for the COOH, should I show the double bond on the O, or is it just COOH?
Either the show karna tha, lekin over here he's just asking for, he hasn't told you whether you should draw a fully displayed or not. Is that clear?
Yes, sir.
Achha, carbocations, which ones are more stable? Primary carbocations or secondary carbocations?
Secondary.
Remember, secondary, tertiary are even more stable. Primary carbocations, why are they more stable? Because they've got two alkyl chains. And alkyl chains have what? They have an electron donating effect. So if they have an electron donating effect, the charge density on the carbocation decreases. It becomes less reactive and it becomes more stable, easily formed. So यहाँ पे लिखना है कि this one is more stable. Why? Because it's got more electron donating alkyl chains. So it's got more electron donating alkyl chains, which decreases its charge density. So, okay. You have to draw the mechanism of electrophilic addition. Okay? So what is the mechanism that double bond, the electrons over here are going to be repelled? The positive H over here will attract electrons. और अगले step पे क्या होगा कि a carbocation gets formed, उसे show किया हुआ है. Who goes and gets attached to this carbocation? It's going to be Br minus 1 that's going to go. तो ये आपका electrophilic addition का mechanism है, ठीक है? It's given over here. ये वाला. Okay, whenever you have a double bond, it's going to repel electrons, polarize the HBr molecule. The positive H will get attached to it. Carbocation gets formed. The Br minus 1 then comes in and joins the carbocation. Okay? Ye bhi clear?
Yes, sir.
Yes, sir.
ये halogenoalkanes का mechanism क्या होता है whenever a halogenoalkane reacts?
O says it, nucleophilic substitution.
Okay. So remember, all halogenoalkane reactions, nucleophilic substitution reactions, OH minus 1, Cl minus 1, or NH3. Okay, the three nucleophiles that react with it. तो उसका mechanism क्या होता है? उसका mechanism ये होता है कि for a primary halogenoalkane, you've got an SN2 mechanism, which is the OH minus 1 attacks the carbon and the Cl gets knocked out, okay, from the other side. Or you have a tertiary halogenoalkane where the Cl gets knocked out first, carbocation then waits for the nucleophile to come in and join with it. So here is a part that's nucleophilic substitution. That's an SN reaction. फिर वो कह रहा है कि this is a ketone and a carboxylic acid. Remember, both ketones and carboxylic acids, they get carboxylic acid भी reduce हो जाता है और जो ketone है that also gets reduced. They all get reduced back to alcohols. तो यहाँ पे he's reducing it. To complete the equation using structural formulas to represent this reaction. So it can be reduced. So we're going to reduce it. क्या होगा उससे? CH3 जो ketone वाला part है, that will turn back into an alcohol. So it's going to become CHNOH. और जो carboxylic acid वाला part है, that will also turn into an alcohol. So it's going to become CH2OH. उसको expand करके देख लो. The ketone will get reduced to an alcohol. The carboxylic acid will also get reduced to an. और equation लिखते हो कार्ब है उससे क्या कि 8 से represent करो. So I guess that's it. कितने H add हो रहे हैं? 2 over here, and I think
Is there any water?
ये water होगा क्योंकि oxygens कम भी हो रहे हैं. So 3 oxygens over here. There are 2 oxygens over here, so I have to add a water molecule. Now the oxygens are complete. Hydrogens कितने हो गए? That's 3, 4, 5, 6, 7, 8, 9, 10. यहाँ पे कितने? That's 4. So 6 चाहिए. So there's going to be 6H. Is this clear?
Yes.
That's an Na cation की electronic configuration. That's 1s2, 2s2, 10 electrons, 2p6. That's it. Why does the radius increase? Because you've got more shells. ठीक है, you've got more shells. तो आपका radius obviously increase हो रहा है. चलो ठीक है, ये पेपर खत्म हो गए. फिर नेक्स्ट टाइम दूसरा करते हैं, ठीक है?
Okay, sir.
Allah Hafiz.
ठीक है, ओके.